So today in section 413, we're going to talk about graphing trig functions with some familiar transformations. So before we do anything else, let's just very quickly remind ourselves from yesterday what one period of a sine and cosine graph looked like using those 5 key points. Right, so we said a sine curve is going to start on the midline. At pi over 2, it goes up to 1. At pi, it's back on the midline. 3 pi over 2, it's down at -1, and at 2 pi, it's back on the midline. And so we make that sad face, and we make that happy face, and we get that S kind of shape that we see. So one period of a sine graph. I'm going to go and use my pink pen to draw in that midline. Awesome. So there's 5 key points. If we talk about our cosine graph, now remember, they're the same graph, but when we graph one period, they do look a little different. Cosine graph is going to start at the top, then hit the midline, down at -1, back to the midline, up to the top. So again, I'll draw in that midline with my pink pen. It's on the x-axis, halfway between the top and the bottom. I'm going to connect the 3 points in the middle with that nice C shape, and then we're going to curl our edges outward to create that peak, or that wave that will continue then going down on the other side. So they are the same graph, we're just looking at them a little bit differently, right? Little different portions. What we're going to look at today is just in general what that graphing form tells us. So when we graph a sine or cosine function, it will help to draw the midline first and then figure out how high and how low those key points are going to go from there. So here's what we would call graphing form for sine and cosine, very similar to graphing form for anything that we've done in the last 2 years, where we've got our A out in front, that's our vertical stretch. We've got our H on the inside, our K on the outside, there's our locator point. So all of that looks familiar. I might just change the vocabulary a little bit. I'm actually going to grab my calculator here, and I have a couple things set up for us, if I can get rid of some of that glare there. There we go. Okay. So here's what I have, is I've graphed on the calculator the exact same thing with H's and K's and A's, and I'm going to be able to change that value up at the top. What I see right now is this sine graph. The A value is 1, the K is 0, the H is 0. I also drew, had the calculator draw in the midline. Okay, I'm going to clear this out, but just to get rid of the clutter here. Whoop, I didn't though, did I? There we go. All right. So let's talk about what happens if I change K. So I want you to just watch the graph. As K gets bigger, what do you notice? You notice our graph is moving up and our midline is moving up. In fact, if K is 4, look at that, the midline is up there at 4. K is 3, K is 2, K is 1, 0. -1, negative. So that K value, what used to be the Y coordinate of our locator point, is actually going to tell us where our midline is. So I'm going to go back, whoops, sorry. I'm going to go back up to 0. Let's go write that down. So this K at the end, that's going to be our midline. I can even write it on here. Y equals K. That's going to be this, center line. I even use a dash line because it's not the graph, it's just helping us create the graph. Okay. All right, I'm going to grab my calculator back. So K is going to go back to 0, and let's look at H. So I want to make H bigger. And what's happening to the graph? It's just sliding to the right. And now it's just sliding to the left. Right? So that's not new for us. That inside number, that's our horizontal shift. We're going to be calling it the phase shift. Just a no vocabulary word, but it doesn't change the fact that it's still a horizontal shift, side to side. Okay. All right. And let's make this go back to 0. Went too far. Great. Let's talk about A. As A gets bigger, the midline's not moving, the x-intercept isn't moving, the graph is stretching, it's getting taller, right? it's the vertical stretch. But we also notice that the distance from the red line up to the blue line or down is getting bigger, or now it's getting smaller, right? The amplitude is changing. So again, A technically is the vertical shift, but we can also call it the amplitude. And remember, amplitude is the distance from the midline to the highest or lowest points. So this is going to be my A, and that's going to be my A. Okay. Now, one more thing on the calculator. I just went up to +1. I'm going to change it to a -1. I'm going to go back to +1. And I'm going to go back to -1. Do you notice the graph is flipping over? Right? It was up here, and now this first part is down here. So that doesn't surprise us, right? When you multiply a function by negative, we've been knowing forever it flips over, right? So I'm going to just jot that down, right? If A is negative, we have a vertical flip, which means instead of a sine graph going up first, it's going to go down first. Or instead of a cosine starting at the top, it's going to start at the bottom. Okay? All right. So let's put all this together. We're just going to graph some functions by first determining where that midline is going to sit, if we have a horizontal shift, and then our amplitude. Now, I'm going to do these two first. I'm always going to start with the midline and the amplitude. So when I look at this equation, it says 3 sine of x minus 2. It does not say x minus 2, right? There's nothing inside with that x, so we're going to be careful with that. All right, so let's see. My midline, my k value is -2, so I'm going to go down here and just get a dashed line at -2. My amplitude is 3, which means from the midline I'm going to go up 3 or down 3. So I'm just kind of making little marks here to show where my graph is going to live. Other than that, that's the only change we have. So it is a sine graph. A sine graph starts on the midline, then it goes up to the top. Here's my top. Comes back to the midline, down to the bottom, back to the midline. And we can connect those in that nice wave shape. Now, that's just one period. We've got all this graph paper. We could certainly keep going. Down to the bottom, back to the midline, up to the top, back to the midline, right? So basically, just kind of copy and paste that shape or continue that pattern. And then it would just keep on going. You can put some arrows on the ends. Okay. Good. Let's take a look at the next one. We have y equals -2 cosine of x plus 1. All right, well, here's my vertical shift is up at 1. Now, technically, my amplitude is 2, but I'm also going to be flipping the graph over because it's a -2. All right, so from the vertical shift, we're either going to go up 2 or down 2. That means my entire graph is going to sit between -1 and 3. And it is a cosine graph that's been flipped. So remember back here, we said if you flip it over, instead of starting at the top, you're going to start at the bottom. All right, so at x equals 0, I'm going to be at the bottom. Then I go to the midline, up to the top, back to the midline, back to the bottom. Let's connect the 3 in the middle first to get that nice C shape, and then curl your edges out. I'm just going to keep going. Draw another section or another cycle. Connect the 3 in the middle, curl your edges out, right? And that's why we do that, because we're trying to get to that peak or valley of this graph. Okay. Now we've got some questions at the bottom. What is the maximum value? Oh, on this graph, what is the highest point we ever reach? It's 3. The minimum value, or the lowest the graph ever gets, is -1. We could have answered that question before we did any graphing, right? We had those numbers right here. All right, let's take a look at the next one. So we have y equals -6 times the sine of x plus pi. Look at that on the inside. So we're going to have a phase shift, and it's going to go to the left pi, right? We knew that. We've been doing that since Algebra 2, right? When it says x plus pi, we actually subtract pi. Let's see, our vertical shift, or our midline, is at 0. We can draw that in. My amplitude is 6, which means from here we're going to go up 6, which is at the very top, or down 6, very bottom. And the negative says we're going to flip that graph over. All right, so we're not starting at 0, we're going to the left pi. But a sine graph starts on the midline, so okay. But if I'm flipping it over, I'm not going to go up first, I'm going to go down first. So at my next, I'm not going to say tick mark, but with 2 boxes over, I'm going down to the bottom, back to the midline, up to the top, back to the midline. And so there's my one period of a sine graph, right? So we've shifted it to the left and it goes down. But we have the room, let's just keep going, right? So I'm going to go down to the bottom, back to the midline, or backwards up to the top and back to the midline, right? So, you know, maybe put some arrows on the ends because we're just going to keep on going. Now, let's see, I'm going to grab my purple marker here. The original graph we had, and I should grab a thicker marker here, was this one, right? We said, okay, yeah, we moved it to the left pi and we flipped it over. That was our original graph. I'm like, yeah, fine. But really, if I highlight, I'm going to use a black, but if I highlight another portion, I should still have grabbed a thicker marker. Doesn't this look like a regular old sine graph with an amplitude of 6, right? Starts on the midline, goes up, then back, then down, then up. I think moving it to the left pi and flipping it over kind of negated each other because really we ended up with a regular old sine graph. So just kind of pointing that out. Trig functions are interesting that way. Multiple transformations can result in no transformation. All right. Now that I made a mess, let's just kind of remind ourselves, when we do graph a periodic function, do not forget the graph goes on forever. The domain is -infinity to infinity. The range is essentially like asking about the max and the min, but we're going to write it in interval notation from smallest to biggest, -6 to 6. All right, let's take a look at this next one. So I see my vertical shift is up 5, or my midline is up here at 5. What's my amplitude? Right? The invisible number in front is a 1. So I'm either going to go up 1 or down 1 from that midline. So my entire graph is going to sit all the way up here. And then this is my phase shift. I'm going to go to the right, pi over 4. Now, pi is 4 boxes. Pi over 4 is 1 box. So I'm just going to move the entire graph to the right, pi over 4. So remember, a cosine graph is going to start at the top, which would be here, but now I'm going to go over to the right. So I'm going to start here. 2 boxes later, I'm on the midline. 2 boxes later, I'm down at the bottom. Back to the midline, back to the top. Connect the 3 points in the middle, and then curl the edges out. And just keep going. Every 2 boxes, we're alternating between a 1, the midline, and a -1. Good. All right, let's finish up with these last 2 here. It says use the graph of sine of x to determine all solutions to this equation, sine x equals -1, on the interval negative 2 pi to 2 pi. So I gave us graph paper that goes from negative 2 pi to 2 pi. It's really not that much different than the graph paper we've been using, except I don't have all these extra gray lines in there. So just be careful. This is pi, which means this one is pi over 2. Okay, so I don't have the pi over 4s in there. All right, let's see. A sine graph starts on the midline, goes up to the top, back to the midline, down to the bottom, back to the midline. All of that gets done before I get to pi over 2, right? So the graph paper is slightly different. We'll just pay attention to that. So I went ahead and graphed that function. And then I'm going to go ahead and graph that function, which is just y equals negative 1, which is just a horizontal line. Well, I want to know when they're equal, when they intersect. That happens at negative pi over 2. And then this one, let's see if this is 1 pi over 2. That's 1 pi over 2, 2 pi over 2, 3 pi over 2. Just like we count around the unit circle, we can count subdivisions on an x-axis. Okay. All right, last one. Use a graph to determine how many solutions exist for 3 sine of x plus 2 equals 0. All right, well, I'm just going to go ahead and graph it then. The midline is up here at 2. And the amplitude is 3. Well, I didn't get great graph paper, did I? 1, 2. So the top is going to be up here, and the bottom is going to be down here. Other than that, though, it's just a normal old sine curve. So let's see. Sine starts on the midline. At pi over 2, watch the graph paper, it's going to go up to the top. And then at pi, it's back at the midline. And then we'll just reverse and keep that pattern going. So I apologize for the poor graph paper there. We could have done it a little bit differently, but that's okay. So just with the way it was given to me, 3 sine of x plus 2, I graphed that. And now I want to know, when does it equal 0? Well, there's 0. And it doesn't say what are the solutions. It says how many. 1, 2, 3, 4, 5, 6. So this is kind of tying some things in from our lesson from yesterday, right? Whether you have your calculator or you're graphing by hand, you can use a graph to help you think about how many solutions you have, or potentially find those solutions.